Good morning, I'm Dr. Sonali here. We are here on Education on Cloud. For class 10 science, we have a chapter named Metals and Non-Metals. All of you are familiar in the periodic table. The metals are the substances which are very good conductor of electricity, which are having luster, okay, and non-metals are generally not very good conductors except graphite. Graphite is a very good conductor, but except that non-metals are not conducting, they are not lustrous also, okay. So like carbon, sulfur and another oxygen, nitrogen are the non-metals, and copper, iron, aluminium are the metals. So let us see here. Elements is a substance that cannot be further subdivided into simpler substance. They are called elements. Elements only can be divided into metal, non-metal and metalloids, okay. So copper, chlorine, sodium, this copper is metal, chlorine is non-metal, again sodium is metal, like that. These are called elements which cannot be further subdivided. Metals are the elements that form positively charged ions by losing electrons to form their valence shell. Now we can see here sodium. Sodium outermost electrons, if we see here, outermost electrons, if we see here, sodium has one extra electron. After losing this electron, the nearest shell will have 8 electrons, that is called octet. So when octet is there, stability, it is considered outermost 8 electrons are there in valence shell, that is considered as the stable configuration, okay. Valence shell means the outermost orbital, there should be 8 electrons, that is called valence shell, okay. So now one electron is lost and Na becomes Na plus ion. After losing electron, it will be positive ion. After gaining electron, it will be negative ion, okay. So now this kind of metals are losing electrons, and they from their valence shell, okay, to give positive ions, and they can only form the oxides which are basic in nature. So sodium oxide is basic in nature, for example. Like this, non-metals are the elements which form negatively charged ion by accepting an electron. Now if we say the outermost configuration for chlorine is 2, 8 and 7. Now 7 means giving 7 electrons is very difficult, because lot of energy is required by removal of every electron. So instead of that, taking one electron in outermost orbit is more easier. So it will be accepting one electron from any other species, and it will be completing octet in its outermost. And when it completes octet, when it accepts electron, it will be into a negatively charged ion, anion, okay. So it will be giving valence shell and form acidic or neutral oxides. Now most acidic oxides will be here in chlorine. There is, for example, dichloroheptoxide. Dichloro means 2 chlorine, hepta means there are 7 oxygen, so hepta oxide, Cl2O7, okay. Similarly, all metals have 1, 2, 3 electrons in their valence shell. We can see here valence shell is outermost shell, outermost orbital, where whatever number of electrons are present are called valence electrons, and that shell is called valence shell, because in chemical combination that outermost electrons only takes part, okay. So like for example, atomic number of sodium is 11. So how we will write the electronic configuration, we have learned to write in previous classes. So near the nucleus there will be 2 electron, then 8, then 18, like that, and so on. So 2, 8 and 1, total number of this makes 11. 8 plus 2, 10 plus 1, 11, correct. So 1 is outermost electron. So sodium will have what is written here, they have 1, 2, 3 electrons in outermost. So 1 electron is present in outermost orbital of sodium. Similarly, magnesium has atomic number 12. So 2, 8 and 2. So outermost how many electrons are present? 2, okay. Then aluminium will have 13. So 2, 8 and 3. So outermost there will be 3 electrons. So now by loss of this electron, they can attain octet. Octet means the next penultimate shell will have octet. So when they lose electron, now Na will lose 1 electron, so Na becomes Na plus, okay. Mg will lose 2 electrons, so Mg becomes Mg2 plus. Al will lose 3 electrons, so Al become Al3 plus. Like that, cations will be obtained by loss of electrons. And same way, non-metals will have 4 to 7 electrons in valence shell. Like for example, if we are seeing chlorine, atomic number is 17. So 2, 8, 7. So outermost there are how many electrons? There are 7 electrons. So by taking 1 electron, it becomes octet will be completed. Carbon will have outermost atomic number of carbon is 6 and 2, 4. So outermost, what we have discussed here, how much electron? 4 to 7. So I have shown you all the examples where outermost 4, 5, 6 and 7, like carbon, nitrogen, oxygen and chlorine. So outermost valence shell, these many electrons are present. Now physical properties of metals, if we say, like what are the metals? Mainly utilized metals are iron, copper, aluminium. So they are solids by nature, they are hard, they have luster, okay, they have high densities, okay. So these are the main characteristic. Then they have high melting points. And why they are having high melting points? Like melting of iron, we require a very high melting point torch, which can be welding or which can be melting it. Why? Because the melting point of iron is very, very high. So are malleable and ductile, means it can be beaten into sheets or it can be drawn into wires also, okay. So they are ductile means drawn into wire, malleable means beaten into sheets. They have high tensile strength, okay, means they can whatever load bearing capacity is very good, that is called tensile strength, okay. And are good conductor of heat and electricity. Generally copper and aluminiums are used for all kind of wiring at household. Why? Because they are very good conductor of electricity. They are monoatomic, like iron, one atom is there, copper, single atom is there, so they are called monoatomic. And they can form alloys. Alloys means making use of two or more metals properties, so we are mixing them, they are called alloying. So like stainless steel is one of the example which you are using at home. So stainless steel is the alloy of iron. Iron means major percentage of iron, then iron will be mixed with cobalt, nickel, carbon, very little percentage, and iron will be converted into stainless steel. So stainless steel is an alloy of iron. Why it is required? Because iron is having lot of strength, iron is the most strongest element, okay, but the disadvantage is the rusting. Iron undergoes rusting whenever it comes in contact with any kind of moisture or moist air. So that is why, to prevent that rusting, it can be alloyed with any other metals. So stainless steel doesn't rust, okay. So like that, so making use of the property strength of iron as well as coming over the disadvantage also. Now non-metal, if we see the property, like carbon, sulfur, oxygen are non-metals. They are generally brittle solids or gases, okay. They are soft by nature and they have low densities. Opposite to solids, we are saying they are not having any luster, they have very low melting points, okay, and are not malleable. They cannot be made into sheets or they cannot be drawn into wires also, okay. They are having no tensile strength, they are very weak, they does not have tensile strength, and they are bad conductor of heat and electricity, okay, because there are no free mobile electrons. Now I have discussed this in previous classes, for electric current or heat going from one end to another and some medium is required. So in solids always it goes via electrons, and in liquid or molten state it goes via always ions. So there is passage for electric current is provided via ions or electrons. So here there are no free ions, so that is why they are not able to conduct heat and electricity. So they are polyatomic, like for example sulfur S8 is there, there are 8 atoms, then do not form alloys, okay, difficult to form alloys. Then actually carbon is used in stainless steel, but carbon is an exception, otherwise also in other properties other than that we are talking. So chemical properties of metals. Metals are generally reacting with oxygen to form their oxides, which are basic in nature. So like for example we are talking sodium reacts with oxygen to give basic oxide, sodium oxide. Then metal oxides of aluminium, zinc, lead, tin react with alkalis as well as acids. So they are, such oxides are called amphoteric. Ampho word is used for both. So they have acidic behavior as well as basic behavior. Like for example aluminium oxide is an amphoteric oxide. Aluminium oxide reacts with HCl to give aluminium chloride. Similarly aluminium oxide reacts with NaOH to give sodium aluminate. So it can react with acid as well as base. When it reacts with acid it behaves like a base, when it reacts with a base it behaves like acid. So that kind of property you would have studied, like frog is called amphibian. Why? Because frog can stay inside the water as well as on the earth also. So amphi word is used for both activities. So these kind of oxides can behave like a acid as well as base, depends on the conditions. Okay, so amphoteric oxides. Now active metals like potassium, sodium, calcium, magnesium, aluminium, zinc and iron reacts with water or steam to form their oxides or hydroxides. Okay, like for example, most reactive metal potassium reacts with water to give potassium hydroxide, which is very strong base, and hydrogen gas is liberated. Then active metals reacts with dilute mineral acid to form their respective salts and hydrogen gas. Like for example, sodium is also reacts with HCl, mineral acid, hydrochloric acid to give sodium chloride, and hydrogen gas is liberated. Okay, so active metal displaces less active metal from their aqueous salt solution. The reaction in which takes place is called chemical displacement. Now we can see the reactivity series where zinc is placed above copper, and zinc is more reactive than copper. So zinc can displace copper from its salt solution, copper sulfate solution, because zinc is more reactive than copper. Okay, so this is called displacement reaction. Then a table of metal arranged in order of their decreasing chemical reactivity is only called metal reactivity series. According to this, the potassium will be the most reactive and platinum will be the least reactive. Okay, so there it will be placed like this, ki above hydrogen elements are reactive, below hydrogen like copper, platinum, gold, silver are less reactive elements, like that. Okay, and on top reactivity series it will be potassium, sodium, magnesium, copper, zinc, iron, all. Okay, then not copper, zinc. Okay, copper is below hydrogen. Then chemical properties of non-metals: reacts generally with oxygen to form their oxides, which are either neutral or acidic in nature. We can see here carbon reacts with oxygen to give carbon dioxide, or we can say neutral oxides of non-metals like carbon monoxide, nitrogen oxide, water and nitrous oxides. Okay, so these are non-metals, do not displace hydrogen to form water or dilute mineral acid, opposite to metals. And then non-metals reacts with one another to form covalent compound. When two or more non-metals combine, you get a covalent compound. Like hydrogen and oxygen, both are non-metal, they bonded together by covalent compound, and the covalent compound is obtained as a water. Then we have non-metal reacts with metals to form ionic compounds, like sodium is a metal here and chlorine is a non-metal. When they combine, you get sodium chloride, which is an ionic compound. Now an atom or an ion having duplet or octet configuration. Duplet means outermost 2 electrons completed, or octet means outermost 8 electron completed. Here 2 electrons are there, so this is called duplet, and here 8 electrons in outermost orbit, which is called octet. So when they have this kind of configuration, they are considered as very stable. Okay, like noble gases is said to be in minimum state of energy, and hence it is chemically inactive. So that is why noble gases has another name, inert gas also, because they are non-reactive. Why they are non-reactive? Because their outermost configuration is satisfied, so they don't lose or gain electron, and they do not take part in chemical combination. So helium, neon, argon, radon, krypton, xenon, all noble gases are having octet completed, except helium. Helium will have duplet completed because atomic number of helium is small. Now the atom of an element can attain stable configuration for nearest noble gas. How they can attain? By loss of electron or by gain of electron. Now we can see by donating one or more electron from their valence shell to another atom. Now here the outermost configuration is 2, 8, 1. So by donating this electron to this, you are getting it 2, 8. Now this electron is lost, so you are having octet is completed. When octet is completed, stable configuration. Then here by accepting one or more electron in the valence shell from another, here the configuration is 2, 8, 7. So by accepting one electron here, you are getting it 2, 8, 8. So outermost 8 electrons are there, completion of octet. But here because it is gained, so it is negatively charged ion. Because it is lost here, so here it is positively charged ions. Okay, so now sharing by from their valence shell with another atom, like hydrogen, each hydrogen has one electron in outermost. If they share, they can form a hydrogen molecule. So they can share and form a molecule. The atom which accepts or donates electron from its valence shell so as to acquire a configuration of the nearest noble gas is electrically charged and becomes an ion. Now by loss of electron, sodium becomes positive ion, cation. Okay, Na plus positive ion. Same way, if we can say here the metal generally donate electron from their valence shell and hence positively charged ions. These are, just now we have seen, positively charged Na plus, Ca2 plus, Mg2 plus, all. Okay, so these positively charged ions are called cations because they discharge the cathode to form the neutral atom. Okay. Now the non-metals generally accepts electron in their valence shell, hence they are forming negatively charged ion. The negatively charged ions are called anions. Okay, so now we can see here anions is obtained by gain of electron, anions. Okay, so this is called chlorine anions. So they discharge at the anode to form neutral atom. Now characteristics of cations. If we talk about cation, only metal form cations because they have 1 to 3 electrons in their valence shell which they can easily donate to acquire a stable configuration of nearest noble gas. So Na has outermost 1 electron which can be given, so Na becomes Na plus. Mg has Mg or Ca both are having outermost 2 electrons which can be lost to give Ca2 plus. Aluminium has outermost 3 electrons which can be lost to form Al3 plus. So this is plus 1, plus 2, plus 3, this kind of ions can be obtained from 1 to 3 electrons can be donated. Okay. There is no change in atomic number of an element. After giving this, atomic number will not change after loss of electron. Why? Because number of protons is same. Okay, so protons is not coming out of the nucleus. So because number of protons do not change. Okay, remember this properly. The atomic radii of cation is smaller than the neutral atom because of the disappearance of valence shell. Now atomic radii, see this is a parent atom and this is after that ionic radius. So this is small. Why? Because here 2, 8, 1, 3 atomic radius was 3 orbitals was there. Now after loss of 1 electron, that orbital is over. That is why there are only now 2 orbitals. So that is why atomic radius of cation is smaller than the parent atom. Okay. Here this should be Na plus. Yeah, this is Na plus. Now only characteristics of anions, only non-metals form anions because they have 4 to 7 electrons in outermost. Here we are talking about chlorine which has 7 electrons in outermost. By gain of 1 electron there will be 8 electrons. Okay, thus they accept electron in their valence shell to acquire a stable configuration of nearest noble gas. So there is no change in atomic number of an anion as the number of protons in the state also same in the neutral atom always. Okay, the atomic radius of an anion is slightly increases. Why the radius is increases? Because gain of electron. But electron, your question will be there, electron is gaining in the same orbital. Why? How the size is increasing? Because as the number of electrons increases, repulsion between electron also increases. So due to repulsion, the size will be, pull of the nucleus slightly decreases due to addition of extra electron in the